Okay, so we will continue in the discussion of the convolution sum. Okay, and at this point, we will work on an example 3. So again, no, we recall that on example 2, we have we have we have implemented the convolution sum, or we have found the convolution sum of two finite duration sequences. Okay. Now, in this example, we will attempt to determine, okay, the or how the convolution sum is determined for two infinite duration sequences. So again, pag sinabi niyo infinite duration sequences, yung or sequence, yung length ng sequence niyo is infinite. Okay? So, ayun. Now, let us determine the step response Yn of a relaxed linear time invariant system with impulse response h of n equals 0.5 raised to n times u of n. Okay? So, ganito, no? Kasi yung problem, yung example 3, this is now the problem is stated now in terms of system analysis. Okay, yung example 2 kasi, binigyan ka lang ng dalawang sequence tapos pinahanap sa'yo yung convolution sum. Okay? Ano lang yun, parang mathematical problem lang yun. Pero this time, itong example 3, the problem in example 3 is on the context na gagamitin natin ngayon yung convolution sum sa system. Okay, sa isang system. So, ganito yung natin, no? Ganito yung situation natin sa example 3. So, again, meron kayong system. Okay? You have a system. Now, that system, first thing, is relaxed. Okay? And is linear and time invariant. Okay? And more importantly, it has an impulse response of this Hn. Okay? So, yung Hn na yun yung nagde-describe dun sa system niyo. So, that is Hn. Okay, so since ang system natin is represented by a block, okay, then we can place yung Hn dun sa loob nung block so that it now denotes na yung Hn niyo actually describes or represents the system. Okay, now, this system takes in an input of xn, okay, and produces or generates the output sequence yn. Okay? So, ngayon, ang hinahanap sa atin dito is step response. Okay? Ang hinahanap sa atin dito ay step response. Okay, ano yung step response? So, we define the step response, okay, of a system is the system's output. Okay? The system's output when the input is a unit step sequence. So, step response ang tawag natin sa output sequence. Okay? Step response is the output sequence, okay, if the input fed to the system through the system fed to the system is step input, okay, or unit step sequence u of n. Okay, so ibig sabihin ang x of n natin pala dito is basically ang x of n natin dito, okay, is basically the step signal. Okay, so it means na it means that we have x of n, okay, equals u of n, okay, and then we have to determine y of n, okay, given na ito yung input. Tapos yung system natin is represented by h of n. Now again, sa ganitong perspective, okay, tatandaan natin lagi that the output sequence, okay, the output sequence of a system of an LTI and relaxed system, okay, tandaan na, dapat relax at saka LTI. Kailangan parehong satisfied dyan ng system. Okay? For one thing, if the system is not relaxed and it's not LTI, hindi siya ma-represent ng h of n. Okay, so therefore, kailangan relax siya at LTI siya para ma-represent siya ng h of n. So the output sequence here is then computed as the convolution sum of xn and hn. Okay? So, para ma-compute natin yung output sequence, okay, kukunin natin yung convolution sum ng x of n at saka h of n. Okay? So, yan yung context ng natin, nung problem example 3 natin. Okay? So, ayun. Now, so ito na nga yun. To find the system step response, we use the convolution sum. Okay? So, before we find the output of the system using the convolution sum, okay, we take note that the system is relaxed. Okay, which is stated naman in the problem. Okay? So, pag hindi kasi siya relax, may mga kailangan pa tayong gawin para maitama siya. Okay? Or para magamit natin yung hn at saka convolution sum dun sa system natin. Okay, now, since we will be using the convolution sum, okay, we need now the formula. Okay, we need now the formula for your convolution sum. Okay, so which is given in equation 3. So, ayan. Okay, now we take note here that for your problem, okay, or in this example, we have determined that your inputs to this formula would be u of n, okay, step signal, okay, para sa x of n, at saka para sa h of n, this is 0.5 raised to n u of n. Okay, so ito yung mga inputs dun sa formula natin. Ito at saka ito. Okay, so again every time na magsasubstitute tayo, since ito at saka ito, isa-substitute natin dito. Okay, pag yung x, isa-substitute natin dito. Yung lahat ng n, gagawin natin k. While para sa h, lahat ng n, gagawin natin n minus k. Okay? So, ito, tsaka to, gagawin natin n minus k. So, ayun. So, now, ganito. Based on this formula, okay? So, ang mangyari doon is ganito, no? Pag sinubstitute natin siya, okay, ganito yung itsura niya. This is the summation of u of k, okay, times 0.5 times n minus k times u of n minus k for k equals negative infinity up to positive infinity. So, yan yung magiging itsura nung natin, nung pagka-substitute natin, yan yung magiging itsura ng formula natin. Okay? Pero tatandaan nyo to. Okay, tatandaan nyo to. Merong property ang convolution sum, which we will talk in detail later on. Tawag natin dun is commutative property. Okay? So, ang commutative property, in general, pwede mong pagpalitin ng operands ng isang operation mo. So, ang operation is commutative if the result is the same, or the result is the same regardless of the order of the operands. Okay? So, ibig sabihin, kung commutative si convolution, okay, instead of actually doing the kasi ang nangyari dito, kaya ito naging h of n minus k. Ito yung naging fold and shift. Diyan tayo nag-fold and shift. Okay? So, since commutative si convolution sum, yung fold and shift, pwede natin gawin instead kay x. Okay? Pwede natin gawin instead kay x. Tapos, i-retain lang natin yung signal values ni h. Okay, so, ito yun. Okay. Kapag in-apply nyo yung commutative property sa convolution sum, ang i-fold and shift natin, okay, ang i-fold and shift natin, is yung x instead na yung h. So, pwede yun. Okay? Since convolution sum is commutative. Okay, so ngayon, pag ginawa natin to, okay, pag sinashoot natin ngayon, yung ano natin dito, yung given natin na x of n, which is u of n, at saka yung h of n natin, which is 0.5 raised to n, u of n natin. Okay, this formula becomes the summation of 0.5 raised to k, u of n, u of k, okay, times u of n minus k. Okay, for k equals negative infinity up to positive infinity. Okay. Ngayon, ikumpara niyo yun dun sa nauna natin ginawa. Ito. Let's compare that to this one. Okay. So, makikita nyo na medyo mas, mas simple to. Okay. Kumpara dun sa, or compared dun sa naunang ginawa natin substitution. Okay. So, instead of actually using this, we will use this. Or we will proceed with the solution using this, from this point. Okay? So, that's the thing about the commutative property of the convolution sum. Pwede nyo tingnan between the operands between xn and hn. Okay? Pwede nyo using with the commutative property of the convolution sum. Okay, you can choose between xn so you can choose between xn and hn. You can choose between which you can choose which between xn and hn to fold and shift. Okay, you can choose between xn and hn to fold and shift. Alin sa hn at saka xn yung i-fold and shift natin. So yung usually ang rule natin dyan is yung i-fold and shift nyo yung simpler in form. Okay? So kung sino yung mas simple between xn at saka hn, yun yung i-fold and shift natin. So in this case, between xn at saka hn, xn is simpler than hn. So therefore, yun yung i-fold and shift natin. Ito yung this is what we will fold and shift. Okay? Giving us this formula. So yung formula na ito na, okay? Now, here's the thing. May makikita tayong dalawang step signal dito. Okay, isang UK, tsaka isang u of n minus k. Okay? Essentially, ang gagawin ng dalawang step signal na yan, or step functions na yan, is papalitan niya itong limits na to. Okay? Dahil yan sa mga definitions niya. Okay, so paano nito papalitan yung mga limits? Okay? So we take note that UK, okay, since ang natin dito, ang limits ng summation natin, okay, is from negative infinity up to positive infinity. Okay, so we'll have UK here from negative infinity up to positive infinity. But take note that the step signal UK is defined as 1 for positive k and 0, for 0 and positive k, and 0 siya for negative k. So which means, okay, this would imply na from negative infinity hanggang negative 1, okay, from negative infinity hanggang negative 1, 0 ito. Okay, 0 tong u of k ninyo. Okay? So, kung 0 yan, regardless of the value of the other two factors, okay, regardless of the value of nito, tsaka nito, for these values of k, okay, yung yung product sequence niyo magiging 0. Okay? So, for k from negative 1 from negative infinity hanggang negative 1, okay, the product sequence, uk0, u of k equals 0, and it would imply that the product sequence, okay, becomes 0 also. Okay? So, ayun. Now, on the other hand, tingnan natin to, no? U of n minus k. Okay. Ngayon, ang u of n minus k, tatandaan niyo isa, no? Lift and shift ito. Okay? Or time folded and shifted ito. Okay? So, which means, kung nagmula yan sa nanggaling muna yan sa u of negative k. Okay? Ngayon, kung yung u of negative k nyo, since flipped yan, ibig sabihin, kung flip version siya nito, ibig sabihin, 1 siya kung 0 and negative yung k nyo. Lahat ng mga 1 niyang values nandun sa negative values of k. At 0 siya pag positive yung k. Okay? 0 siya pag positive yung k. Okay? Sorry. 0 to. Yan. Now, ngayon, isi-shift kasi natin to para maging ganito. Para maging u of n minus k. Pag shift natin ngayon yan, regardless of the amount of shift, tandaan nyo na lahat ng mga values sa kaliwa, okay, is 1. Okay? And lahat ng values ng kaliwa nito sa 0, okay, ay 1. At lahat na nasa kanan ng 0 ay 0. Okay. Ito, may example lang ako. Ayan. So, ngayon, pag shift natin siya, okay, pag in-applyan natin siya ng shift, say for example ito, okay, may 6 dito, no? Pag in-applyan natin siya ngayon ng shift na 6, pansinin nyo na ito yung 6 k equals 6. Ayan, ito. Pansinin nyo na simula 6, okay, at pababa. 6, 5, 4, 3, 2, 1, pababa yan. Okay. Ang value niya, 1. Okay. While, pagkatapos ng 6, so simula 7, ito yun, k equals 7, pataas, 0 na siya. Okay? So, ganun din yan kapag halimbawa, ginawa natin u of, say for example, negative 5 minus k. Okay? Ang magiging value niyan is 1 siya for k less than or equal to negative 5. Okay? Ibig sabihin, bago dumating yung negative 5, hanggang sa negative 5, or k equals negative 5, ang value ng u of k nyo is 1. At 0 siya for k greater than 5. So, ibig sabihin, pag lumpas siya ng 5, nag-6 na yung k nyo, magiging 0 na siya. Okay? So, in general, okay, yun na nga, no? Yung value ng u of n minus k ninyo is 1 for k less than or equal to n. Okay? So, sa kaliwa ng n, 0 siya. 1 siya. Okay? Sa kanan ng n, 0 siya. Okay? So ngayon, ano ngayon ang gagawin doon sa signal natin? Okay? So ano yung gagawin niya doon sa natin? Dito. Okay? It means na pag ang value ng k nyo, okay? Pag ang value ng k nyo, okay, is from negative infinity, okay? From negative infinity hanggang n. Okay? Pag ang value ng niya, binulo ko yun. Kapag ang value ng k nyo is negative infinity hanggang n, okay, ang magiging value ng signal nyo is 1. Okay? And then, from n, okay, or from n plus 1, ibig sabihin, lagpas ng n, okay, hanggang positive infinity, Okay? Ang value ng signal niyo ng u of n minus k niyo equal 0. Okay? So, simula n plus 1, okay, simula n plus 1 hanggang positive infinity, okay, ito, magiging 0 din. Now, at these values of k, regardless kung ano yung value ng mga to, okay, regardless kung ano value ng 0.5 raised to k at saka ng u of k, sa mga values ng k na to, basta ito yung values ng k, mag-0 tong factor na to. Okay? This would still lead to a product sequence of 0. This would lead to a product sequence of 0 equal to 0. So, ibig sabihin, from negative infinity hanggang negative 1, 0 yung product sequence niyo. Okay? And from n plus 1 hanggang positive infinity, 0 din yung product sequence niyo. So, ano nga yung mangyayari dun sa natin? Ano yung mangyayari dun sa signal natin or saan natin, sa summation natin? So, since from negative infinity hanggang negative 1, 0 siya. Okay? At from n plus 1 up to positive infinity, 0 din tong product sequence niyo. It would now be obvious na itong itong limits natin ito, okay, magkakaroon na siya ng value pala. Okay? Hindi magiging 0 yung yung product sequence niya. Okay? Kapag yung k niyo equals 0, okay, simula 0 hanggang n. Okay? So, kasi from if your k is from 0 up to n, okay, yung u of k niyo is equal to 1. Kasi positive yung okay, positive yung p. Okay? While yung u of n minus k niyo, okay, is also 1. Kasi this is 1 when k is less than n. So, magiging 1 din to. So, ibig sabihin, yung limits ng summation natin, papalitan natin ng 0 to n. Okay? And at those values of k, ito, magiging 1. Ito, magiging 1 din. Okay? So, ngayon, pwede natin i-write ngayon yung pwede natin i-write yung formula ninyo. Okay? So, kung marire-write natin yung formula ninyo, okay, magiging ganito siya. Okay? Itong formula natin na to, okay, can be now rewritten, okay, as y of n. This now can be written as y of n equals the summation of 0.5 raised to k, okay, for k equals 0 up to n. Tapos yung dalawang factors na to, since from 0 to n, 1 nga yan pareho. So, times 1 na lang din siya. So, ito na yung may iwan. Okay, so this now is to be written here, applying the definitions of your step signals. Okay, so we now continue with this. Okay, this is now a geometric series. Okay, alam na natin na this one is a geometric series. Okay, in this case, this is a finite geometric series. Okay, finite geometric series siya. Okay, so meron lang siyang length na, or meron siyang haba na n plus 1. Okay, so the sum, okay, of a finite geometric series, okay, again, is provided to us dun sa formula 8 ng lesson 2.1. Okay, so ito na yung nilagay ko na dito. Okay, pero again, kung maghahanap kayo ng mga formulas for sums of geometric sequences, or series to but sequence series yan. Okay, if you would be looking for sums or formulas for sums of geometric series, okay, nandun siya sa formula, nasa lesson 2.1 siya, nasa formula 8. Okay, so ito yung natin, sum ng finite geometric series natin. Okay, given na yung base nung ano nyo, o yung A niyo is not equal to 1, tsaka kung equal to 1 siya. So in this case, ang A natin kasi dito is 0.5. So therefore, dito tayo maghanap sa not equal to 1. Okay? So, now, in this case, makikita rin natin na yung upper limit natin dito is yung small n natin. So we have now the following parameters of our finite geometric series. Okay? So, i-apply natin ngayon yung formula na to. This becomes y of n equals 1 plus a raised to n plus 1 over 1 minus a. So, magiging 1 minus 0.5 raised to n plus 1 over 0.5. Or pag sinimplify natin to, okay, magiging ano yan? 1 minus 0.5 raised to n plus 1 over, magiging 0.5 kasi yung ilalim. And 0.5, 1 over 0.5 natin is actually 2. Okay, so that becomes this one. Okay, so now your output sequence now, okay, your output sequence now is 2 times 1 minus 0.5 raised to n for n greater than or equal to 0. Okay, so obviously, i-define natin yung output sequence nyo for n greater than or equal to 0 since the convolution sum generates the output of a relaxed system. Okay, at pag ang system nyo kasi is relaxed, okay, pag ang system nyo ay relaxed, we tend to think na yung indices nyo na negative would cause would have your output sequence to be 0. Okay? So pag negative yung indices nyo pag negative yung indices nyo on a relaxed system, yung output sequence nyo is 0 kasi nga ito yung ang negative indices kasi or ang values ng nung output sequence niyo, okay? The values of the output sequence when the indices are negative or when the indices are negative is considered to be the state of the system. Okay? So yun yung parang pinaglalagay ng state ng system. Okay? And in this case, since relaxed nga yung system natin, we will now observe na dapat yung state of the system natin should be 0. Okay? Wala dapat nakastore na values dyan. So therefore, itong output sequence na to applies at this interval. Okay? So ngayon, pansinin natin ngayon na yung convolution sum ng infinite duration sequences, okay? The convolution sum of infinite duration sequences is an explicit expression for yn in terms of n. So, ito yung sinasabi ko before, okay, na ang objective natin dito, okay, in the analysis of system, one of our objectives in the analysis of systems is to determine y of n or determine the output sequence, okay, as a function of n. Okay, so which means itong right side natin should just simply be an expression, okay, containing n only as a variable. Okay, so ito na nga yun, yung hinahanap natin. Okay, so ngayon gagawin natin, kasi what we would like is to verify what we would like is to verify the this one, yung results na nakuha natin. Okay, so at this point, we will be using yung numerical computation ng convolution sum, okay, in which we will be modifying yung built-in function ng MATLAB na conv. Okay? So, merong function si MATLAB na conv. Okay, i-modify natin siya and write the fconv na function. Okay, so this is now a custom or a user-defined function. Okay, which is a modification of built-in CONV function of MATLAB. Okay. Function of MATLAB. So essentially, ang CONV function, it actually computes the convolution sum of two sequences. Okay. Medyo i-modify lang natin siya. Okay. Para ma-modify din natin yung para kasabay na ilagay din natin yung indices. Okay. Nung output sequence natin, nung input sequences natin, tsaka nung output sequences natin. Okay. Kasi si MATLAB kasi, yung CONV function niya, it just computes the convolution sum of two sequences. Okay, it computes the convolution sum of two sequences regardless of the time indices. Okay, of basta sa kanya ang indices ng bawat sequences is 1 to kung ilan yung haba ng sequence nyo. Okay, so wala siyang pakialam kung kung ang indices ba niya is from, for example, -1 up to 20, ganun. Okay. Sa kanya, lahat yan 1 hanggang kung gaano kahaba. Okay. So, ganito muna, no? Balikan ko itong example 2 ninyo. Okay, na dalawang finite duration signals. Okay. So, pakita ko lang kung kung paanong ginagamit yung CONV function. Okay. So, we have here the following sequences, H na itong sequence to, tsaka X na ito. Okay. So we define them in MATLAB as follows. Okay. So, you have H to be the array, the row vector 3, 1, 2, 1, -1. Okay. So, ayan. 1, 2, 1, -1. Okay, and then yung X natin is 3, -1, 1, 2, 3, and then 1. Okay. Now, pwede nyo gamitin yung Y equals C, O, N, B, H, K to compute the output sequence Y. Okay. So, pag kinuha natin yan, okay, ang magiging results natin is ito. 9, the sequence 9, 0, 8, 8, 9, 12, 8, 3, -2, -1. Recall that these are the values na nakuha natin dun sa example 2 natin. 9, 0, 8, 8, 9, 12, 8, 3, -2, -1. So, tama nun yung mga values. Kaya lang ito yung problema natin. Ang problema natin dito is that we don't know kung ano yung time index ng 9 at saka yung time index ng -1. Or in this case, lahat ng time indices ito, hindi natin alam. We don't have any idea. Okay? So, para dun yung modification nung function na FCONV. So, yung FCONV function natin, okay, requires for arguments. Okay? So, yung X natin, okay, is the array for your your vector array, row vector that represents your X. Okay? Tapos itong NX, yung kanyang vector that represents the time indices or time index of X. Okay? H naman, okay, is the vector represent or holding the values for your H, for your sequence H. And then yung NH is yung time index, yung vector representing the time index, the corresponding time index for your sequence H. Ang ibibigay sa atin nung function natin is the sequence Y, okay, is the sequence Y, and yung time index vector nung sequence Y natin. So, ngayon, magkakaroon tayo ng idea kung ano yung time indices nung ating sequence Y. Okay? So, pagka ito yung ginamit natin. Ngayon, nandito yung maigli na naman yung function, but this actually involves parang getting the common parang mag-generate ka ng common na index para sa dalawang para dun sa dalawa mong signals. Okay? And taking note na ang magiging first index mo, okay? Ang first index nung first value nung index mo is actually the sum of the first values nung indices ng x at saka ng h. Tapos yung last niya, okay, is actually the sum of the last indices for x and h. Okay? So just to demonstrate, ito siya. Tandaan nyo, this is this yn, kung matatandaan natin, is defined from negative 4 hanggang negative 4, 0, 1, 2, 3, 4, 5. Hanggang 5 siya. Okay? So, tingnan natin ulit balikan ko yung given. So, yung given dito, you'll have your nh to be from or yung time index ng nh no. Okay? Is from negative 2 hanggang 0, 1, 2 hanggang 2 siya. While itong so this is your nh no. Tapos while your xn is defined from negative 2 hanggang 0, 1, 2, 3 hanggang 3. So yun yung nx nyo. So ang malalaman natin na ang magiging convolution sum niya should be defined by from or within the interval ng sum nito, yung pinakamaliit dun sa indices or dun sa interval, pinakamaliit na index dun sa interval ng dalawang i-convolve ninyo, which is negative 4. Okay, tapos ito, okay, yung sum nito, yung dalawang pinakamalaki, which is 5 naman. Okay, so ito yung naan natin kanina doon sa sagot natin. Okay, so ayun, that is how we compute the lowest, okay, and the highest values for your time index of your sequence. So ayun, yun lang yung i-return natin doon. Okay, so gawin natin ngayon is so in addition to defining yung h natin at saka yung x natin, let's also define nh to be again, this is from negative 2 hanggang 2, while ang nx natin is from negative 2 to positive 3. Okay? And then, let's compute y. Okay? Or the convolution, this f1 requires you to have two arguments. Okay? Kailangan may dalawang output arguments kasi kayo, so dapat ilagay natin siya sa array. Okay? So this is y at saka ny. Okay? Equal yan sa f, c, o, and b ng x, tapos yung time index corresponding to vector x, and then h, then the nh, okay, the time index corresponding to vector h. Okay? So, evaluating that, okay? So, malaman natin ngayon na gawin natin siyang column, no? So, lagyan natin. So, let's tabulate yung yung yn tsaka n natin, no? Okay, so using this array to table command. Okay, so ayan. Oops. So we'll use the following array to table commands. Medyo nagkamali ako dahil nakalimutan ko lagay ng comma pagkatapos ng variable names na description. Okay, so enter natin to. So we'll have the following table of values. So for n equals negative 4, ang value ng sequence natin is 9. For negative 3, 0, and so on. Which is, now, you can see na consistent dun sa sagot na nakuha natin dun sa example 2. Okay? Now, going back dito. Okay? So, since meron tayong x of n, which is u of n minus u of n, at saka h of n, which is 0.5 raised to n, u of n. Okay? Actually, pwede natin gamitin itong numerical convolution na convolution sum na to. Okay? So, pwede natin gamitin itong numerical convolution sum function na to. Okay? It's just that may caution lang tayo kapag infinite duration sequence yung gagamitin natin to do the numerical convolution sum. Okay? So, unang-una, kapag ang ating sequence ay infinite duration, it means na yung para makuha natin yung eksaktong value ng output sequence, kailangan yung mga duration din na i-define natin dito, itong nx at saka nh, infinite din. Okay? Which is impossible na mangyayari. Okay? Hindi natin magagawa sa MATLAB yun. Okay? So, ang gagawin natin is ganito. Kung infinite si x at saka si h, edi pili lang tayo, i-truncate natin yung length ng x at saka length ng h para maging finite siya. So, pili lang tayo ng duration o pili lang tayo ng interval para sa x ninyo at para sa h ninyo. Okay? Tapos, i-convolve natin siya. Okay? I-convolve natin siya. Taking note na ang values nung yung magiging values ng convolution sum nila ay equal dun sa infinite duration case hanggang dun sa dulo lang ng mga pinili nyo sa mga dulo ng nx at saka ng nh. But beyond that, hindi na siya mag-iiba na yung values. Okay? Anong ibig sabihin? Ibig sabihin, if we have, for example, in this case, we can choose na yung n ninyo is from -5 to 20. Okay? So ngayon, kung pipili natin na yung n natin from -5 to 20 lang, ibig sabihin, yung convolution sum natin, okay, yung convolution sum natin, hanggang hanggang -5 to 20 lang din. Okay? Titingnan lang din natin yung values ng y of n from -5 hanggang 20 lang din. Kasi, pag mababa sa -5 at saka mataas sa +20, okay, yung values, yung output sequence ng convolution sum mo, iba na yung values niya dun sa infinite duration case. Okay, so since magaan tayo, mag-approximate lang tayo ng mag-approximate tayo ng solution para dun sa infinite duration case. Yung truncation from infinite duration to finite duration sequences would only make the numerical convolution true, okay, for n that corresponds to both x at saka h. So, ayun. So, pag pipili tayo ng n for x at saka h, tapos yung y natin, titingnan lang din natin dun sa duration na yun. Pero sa labas nun, wala na siya. Okay? So, ganito, no? So, ginawa ko dito, generate ko yung n from -5 hanggang 20. Actually, dalawang column siya. Okay? So, from -5 to 20, generate natin siya. Okay, so ito yung values ng x. Okay? Ito yung values ng h. So, take note na yung x niyo is u of n. Tapos yung h niyo is 0.5 raised to n, u of n. Okay? So, makita natin na since yung x niyo is step signal, so 0 siya for negative values of n. Ito rin 0 din to for negative values of n. Kasi nakamultiply si u of n dito sa exponential niyo. Okay, while si x is 1, okay, pag positive si n. Okay? So, for positive n, 1 si ano. So, ito naman, pag positive si n, 0.5 raised to n siya. So, ito yung values ng 0.5 raised to n niyo. Okay? So, now, we now compute the numerical convolutions. We now do the numerical computation of the convolution sum. Okay? for n from negative 5 to 20. So, ito na yung commands. No? So, again, we are using common time indices for your x and h. Okay? And C, na since ang magiging yn nyo dito, okay, is from ang y of n nyo dito is magiging negative 10 hanggang 40. Okay? I-ignore natin yung negative 10, yung values ng y from negative 10 hanggang negative 6, at saka from 21 hanggang 40. So sa mga ranges na yan ng my, okay, ignore the values of y. Okay? Kasi nga erroneous yan. Okay? Ito yung epekto ng this is the effect of truncating infinite duration sequences para maging finite duration sequences sila. Just to allow numerical computation of the convolution sum. Okay? So, ayun ngayon siya. So, mangyari ngayon, it will result to the following sequence. So, yun nga, titingnan natin siya from negative 5 hanggang 20 lang. Okay? So, ito yung magiging result ng y of n ninyo. So, 0 siya, okay, for negative values of n. Tapos, ito yung values, yung sequence niyo for n greater than or equal to 0. Okay? Actually, it's 0, between 0 at saka 20. Okay? So, yun siya. Okay? So, ayun. Now, what I want to do is to check if these same numbers or these same values would be generated by this expression na na-compute natin using the convolution sum. Okay, ito yung naging result nung nung analytic solution nung convolution sum natin for two infinite duration sequences. Okay, so ang gusto kong mangyari is that I'll replace n with 0, okay, to 20. Okay, and of course yung negative 5 hanggang negative 1, it should imply na dapat 0 siya. Okay, again, ang natin dito, ang y, nabanggit natin kanina, or it was stated earlier that y of n here is defined for n greater than or equal to 0. Okay, so ibig sabihin, for n less than 0, yung y of n niyo ay 0. Okay, so ayun. So nevertheless, ginamit ko na rin yung negative 5 to 20, pero ginamitan ko siya ng ginamitan ko siya ng u of n. Okay, para mag-serial negative values of n. Okay, so ito ngayon yung mga na-generate na values nito. So take note na ito yung formula na in-implement natin. So itong formula ito yan. Okay, yung nakuha nating sagot dun sa analytic solution ng convolution sum. So ito yung mga nakuha nating okay, ito yung mga nakuha nating values. Okay, using this Okay, so pansinin nyo na per n, okay, per values of n, pareho yan. Okay, so pareho yung sequence na generate niyo. Okay, so ayan, pati yung n equals 14, 16, and so on. So pareho yung na-generate natin. So ito, ginamit natin dito yung fcon function. Ito naman, ito yung expression, ginamit natin yung expression na nakuha natin using analytic solution of the convolution sum. So ano yung conclusion natin? With terms being similar at every n, okay, we can conclusively say that the explicit expression that we have obtained using the analytic solution of the convolution sum, okay, generates the same values as that of the convolution sum algorithm, and therefore, yung those two algorithms, this one or this formula, okay, and that of the convolution sum algorithm are therefore equal processes. So, ibig sabihin, it reinforces the idea na tama yung sagot natin. Yun yung point ko dito. Okay? It reinforces the idea na tama yung sagot natin. Okay? So, ayun. So, the example T0303.m na script is available dun sa ano natin, sa files associated with this topic. Okay? And you can check the codes up there. Okay? So I'll pause I'll again pause the discussion right here. Okay? And continue it on the next recorded lecture. Okay? In that presentation, we will now discuss the properties of convolution and how those properties of convolution relate to how LTI systems are interconnected. Okay? So basically, ang pag-uusapan natin dito is how to first represent your system as block diagrams and how to actually simplify systems, okay, or multiple systems that are connected to each other. Okay, so yun yung magiging discussion natin sa next presentation natin.